42A. We're going to do implicit differentiation today. So far, everything that we've taken the derivative of has been a function. Today we're going to do some non-functions. Can you think of something that you've studied in the past that is not a function? How about that whole chapter 10 in Algebra 2? Differentiation. How about a circle? Is a circle a function?
No.
Yeah, an ellipse, hyperbola. Yes, a sideways parabola. These are all non-functions. No, it's not one-to-one. Right. Okay, so here we go. Now, to do implicit differentiation, we are going to solve for dy dx. Okay, we're still taking the derivative, but we're going to be taking the derivative of y now. Every time we've taken the derivative of y, it's y prime, or dy dx. But we've never had y squared or cubed, and how do you do that? Okay, we've taken the derivative of x, like for example, if you have y equals x squared. When you take the derivative of that, you get y equals dy dx. The derivative of y is dy dx, and the derivative of x squared is 2x. But little did you know, you were actually doing times dx dx the whole time, because you're taking the derivative with respect to x, and dx dx is just 1. Now, when I take the derivative of y, it's dy dx, okay? So I'll just show you, you know what, if you don't understand it, that's okay. There's just a simple trick to do every time. So here we go, number 1. So suppose now we have y squared equals x. And we need to find dy dx. This is a sideways parabola. It's a basic parent function, sideways parabola, goes to the right. It looks like this. Not a function, sideways parabola. Now we're going to find the derivative of that. So here's how you do it. You take the derivative of y squared, which is 2y dy dx. All you need to remember is every time you take the derivative of y, you have to tack on a dy dx to it. It's like it's chain rule. You take the derivative of 2y, but the derivative of y is dy dx. And then the derivative of x is just 1. And so we're finding dy dx. So to solve for dy dx, you're going to divide both sides by 2y. And so your answer would be dy dx equals 1 over 2y. I know, it's weird, right? You've never done that before. It's new to you. Yep, that's all you do. That's all you need to remember. You have to, it is chain rule. You have to tack on, like multiply a dy dx. When you do it with x, you know, it doesn't matter. It just equals 1. But when you do the derivative of y, it's dy dx on top of it. All right, so let's do number 2. Okay, I'm going to give you a circle centered at the origin with radius 5. X squared plus y squared equals 25. Okay, there's a circle. We are going to find dy dx. Find dy dx. Basically, we're solving for dy dx, okay? So let's go ahead and we'll take the derivative of every single piece. So what's the derivative of x squared? That does not change, okay? Derivative of x squared is 2x. The derivative of y squared is 2y dy dx equals the derivative of 25, 0. Okay? Now solve for dy dx. Subtract 2x to the other side. Subtract 2x. And then divide by 2y. So dy dx equals negative 2x over 2y. And so dy dx would equal, perfect. So the derivative of that circle is negative x over y. And that would be your answer. Okay? So then I could ask you a question like this. What is the slope of the tangent at the point 3, -4. Okay? So this is what we have. We have a circle with radius 5, and at the point 3, -4, right here, we're trying to find the slope of the tangent, which would be that line right there. +3, -4, that's this point. It is on the circle. Oops. +3, -4. Yes, good. So you went up to the derivative, dy dx, and you plugged in 3 for x, and you plugged in -4 for y, and so the slope of the tangent is 3/4. There you go. Perfect. Yay. Isn't that fun? I know, right? All right, let's do this one now. Let's do a little harder now. You ready? Number 3. Now that you kind of have the hang of it, maybe, let's see about this one. How about 2x is equal to cosine of y?
Whoa.
Cozy.
Uh-oh.
It's very cozy. All right, here we go. Now we need to find the derivative, and be careful. Okay, I'll walk you through this one. We'll find the derivative of 2x is 2. The derivative of cosine y is -sine y, and then what? Yes, times dy dx. Anytime you're taking the derivative with y in it, just put it on the end, even if you don't understand it. It is chain rule, though. It is. We took the derivative of cosine, which is -sine. Then we took the derivative of y, which is dy dx. You get that? The derivative of y is dy dx. Okay, now we need to solve for dy dx by dividing. So we get, I'll just write it over here, dy dx equals -2 over sine y, which you can actually go one teeny little step further. Use your trig properties that you know. What is 1 over sine? It's cosecant. So cosecant y. And that would be it. Okay. Let's try this one now. Number 4. 2y, this one's really a little complicated, so pay attention. 2y equals x squared plus the sine of y. Okay. 2y equals x squared plus the sine of y. All right, so let's take all the derivatives, all the things. They're all separate. There's no product rule going on, so we're okay. So the derivative of 2y would be 2 dy dx, exactly. Equals, the derivative of x squared is 2x plus the derivative of sine y, cosine y, dy dx. Perfect. Okay, now the problem is, there's a little teeny problem. We've got 2 dy dx's, right? So what you need to do is get them together on one side and then factor it out. Remember we did something like that earlier in the year. So get your dy dx's all together on one side. So I'm going to subtract cozy over here. Cosine of y equals 2x. So I got my dy dx's on the same side. Just subtracted that over to the other side. Okay. Now go ahead and factor out a dy dx. So you get dy dx. Remember doing this? We did this with, I think it was inverse functions we did this with. And then, it was chapter P, or chapter 1, whatever that was. Equals 2x, and then divide. Exactly. Good job. So dy dx equals 2x over 2 minus cosine of y. It's really one of the other reasons why it's really important not to just write cosine, because cosine of x is very different than cosine of y, especially when you're taking the derivative. All right, I got 2 more. Yeah. And then you get to practice. I'm going to give you a test back today.
Okay, let's go, dude.
All right, number 5.
Can you see Greg's on the screen?
No.
Yeah, actually, type 1 up there.
No. X cubed y equals y. I know, right? All right, so here we go. This is we're going to have to do product rule here. There's a dot right here. See it?
Oh.
I know. You don't see it, right? They're right next to each other. You're like, oh, okay, that's easy. No, that's a product rule. So here we go. No, there's one more harder one coming up. This is A and this is B. So here we go. Are you ready? We're going to go A times B prime. So A is x cubed. B prime is dy dx plus B times A prime. So B is y. A prime is 3x squared. And this is equal to the derivative of y, which is dy dx. Woo! All right, now let's get them all together, the dy dx's. So I'm going to bring this one over to this side. It doesn't matter which way you go. We'll just do that. This right here is 3x squared y. Okay, I'm just going to rewrite that. And then I'm going to subtract x cubed dy dx to the other side. Is everyone okay with that step? Yeah, I did a couple in one. The rest is algebra. See, that was just the calculus part. The rest is the hard part, is algebra. Now go ahead and factor out a dy dx over here. So you get 3x squared y equals, and when you factor out a dy dx, you're left with 1 minus x cubed. Okay, because we factored out the entire dy dx, you're left with 1 there. And then finally, last step is to divide by 1 minus x cubed. So dy dx equals 3x squared y over 1 minus x cubed. That is good, huh? Yeah.
Instead of writing dy dx, I just draw a square every time.
No. The shortcut that you can use, though, is y prime. I'd rather you not use y prime, because later on we're going to take, in Chapter 5, second semester, we're going to take derivatives with respect to time instead of x, and so it's going to matter.
How about I just draw a square at the very end? I just write dy.
No squares. No, this is not hieroglyphics. We are not Egyptians. No, I'm sorry. I don't want to. Doesn't mean you don't get your way. All right, number 6. Number 6. Here we go. All right, last one. Here we go. X squared plus 4y squared equals 16. Okay, that's an ellipse. I don't know if you recognize that from subjects past. We're going to find the second derivative. Okay, we're going to find, we'll call it y double prime for you, people that don't like to write dy dx. I personally like to write dy dx, but that's okay. All right, here we go. So we're going to find the second derivative. You ready? Here we go. So let's first find the first derivative. You probably know how to do that now. This one's not too bad. You go 2x plus 8y dy dx equals 0. Okay? So go ahead and solve for dy dx. We'll subtract 2x to the other side. So you have 8y dy dx equals negative 2x. And then finally divide by 8y. So dy dx equals negative 2x over 8y, which we can reduce to negative x over 4y. Okay, so that is the first derivative. Okay, and if you want to, we can write that as y prime or dy dx. Let's just leave it. You okay with leaving it as dy dx? No? Okay, we'll do y prime. Y prime is equal to negative x over 4y. Okay, now we have to find the second derivative. So the second derivative is found by taking the derivative of the derivative. So here we go. The derivative of y prime is y double prime. And over here we're going to need to use our good friend quotient rule. Okay, so here we go. We're going to do low, d high, minus high, d low. What's the derivative of 4y? 4 dy dx over the square of what's below. We'll just write 16y squared. You can write the whole thing squared if you want to. All right, now let's clean this up a bit. So y double prime equals, we get negative 4y plus, negative times a negative, 4x dy dx all over 16y squared. Okay, now we're going to use substitution. See this dy dx? What was that equal to? Oh, there it is. It's equal to negative x over 4y. Do you see that? We have the first derivative right here, and we found the first derivative way back here. We need to now substitute that back in. So here we go. Y double prime equals negative 4y plus 4x times, what did I say it was equal to? Negative x over 4y, and this is all over 16y squared. Okay, now let's go ahead and simplify this. So here, the 4's can reduce, and we have y double prime equals negative 4y minus x squared over y, and this is all over 16y squared. Okay. Now, unfortunately, we're not allowed to leave fractions within fractions. That breaks our algebra rules. So let's do this. Let's multiply top and bottom by y to get rid of this problem right here. So here we go. We get negative 4y squared minus x squared all over, and what do we get on the bottom? 16y cubed. Now do me a favor, let's factor out a negative 1 up top. Factor out a negative 1, and then switch everything around a little bit. We get x squared plus 4y squared over 16y cubed. Now do you recognize that x squared plus 4y squared? Go back to the very original problem that you wrote down. What does x squared plus 4y squared equal? It equals 16. Isn't that crazy? You go back to the very original, right here, it says x squared plus 4y squared equals 16. So let's substitute that in now. And you get, oh no, negative 16 over 16y cubed. And so the second derivative is simply 1 over y cubed, negative 1 over y cubed. Wasn't that great? Didn't that take up your whole paper too? But you followed it. You know, it was hard, yeah? There's a lot of algebra. There's some fractions. But it was beautiful. Just really gorgeous.